Today we want to take a look at LeetCode question serialize and deserialize binary tree, and we will use Python 3 to do the coding. So you can take a look at the problem statement at LeetCode.com. The goal for this problem is to design an algorithm to serialize a tree and deserialize a binary tree. So there's no restriction on how your algorithm should work. You just need to ensure that the binary tree can be serialized into a string, and this string, here we call it the data, can be deserialized to the original tree. So let's take a look at the example the problem gave us and think about what approach we should take. We have to visit all the nodes here, so we need to think about what method to use to traverse all the nodes. And a natural way to traverse all the nodes is to use preorder traversal. Basically, we take a look at the root first, and then we move on to the left subtree, and then we move on to the right subtree. So in our problem, the root is 1. Then we move on to the left subtree, and then the right subtree. And we take a look at the left subtree, we have 2 as its root, nothing for left and nothing for right child. And for the right subtree, we have 3 as its root, 4 as its left child, and 5 as its right child. And for 4, we have nothing as its left child, nothing as its right child. Similarly, no left or right child for the number 5. So as you can see, if we use a preorder traversal to serialize a tree into a string, is nested. So a natural way to think about it is to use recursion for the algorithm. So we begin with serializing the tree. Take care of the base case. So if not root, so if nothing is in the root, we just simply return pound to signify that's the end of it. Otherwise, we have to go into the left subtree. So we have to cell dot serialize roots dot left. Now again, if nothing is in the left, you just get a pound. And the next thing, we need to take care of the right subtree, so it just cell dot serialize roots dot right. So once we take care of the left subtree and the right subtree, we just return in pre-order traversal order. So it's root dot value, then whatever we get from the left subtree and whatever we get from the right subtree, and that's it for the function to deserialize the root. Now, in order to deserialize, we need to understand each nested parenthesis has 3 components: the root, the left subtree, and the right subtree. So we only need to take care of 3 things. Again, base case, if data 0, which is the root, equal pound. That tells us that there's nothing there, so we return none. Otherwise, the root, so there's something there, is a tree node of the data value at 0, which is the root position. Then we look at the left subtree, so root dot left will equal cell recursion, right? So cell dot deserialize data at the left subtree position, and then root dot right will equal cell dot deserialize the data at the right subtree position. Then we just return the root of the tree. So this problem was classified as hard in LeetCode. It seems like the algorithm, it doesn't take a lot to write, but it could be hard to think about what order of traversal to use and how we go about formatting the string. But the key word in the problem is really, it says no restriction on the algorithm. So you just have to try out all the order: pre-order traversal, in-order traversal, post-order traversal, or layer by layer, and see which is the best approach for you.